Glyphs are data-driven visual entities that represent multidimensional data using different visual channels. Circular glyphs are glyphs with a round shape, which locate in a polar coordinate system. They are widely used in different fields because of their effectiveness in representing multidimensional data. However, the creation of circular glyphs remains a difficult task, due to the demand for design skills and the laborious process even with current ordering tools. In this paper, we present an interactive ordering system, GlyphCreator, to simplify the ordering process by supporting the example-based glyph generation. Given an example circular glyph and multidimensional data, the system can help users quickly create a set of circular glyphs with a similar layout. To implement this system, we first derive a design space for circular glyphs from summarizing the relation of different visual elements. We build a circular glyph dataset based on the design space and train the parsing model based on deep learning to deconstruct a circular glyph bitmap into visual elements. In this video, we demonstrate the process of generating a circular glyph by using GlyphCreator, which is easy and straightforward. Now, we follow Lucy, a junior visualization researcher, to see how to use GlyphCreator. Her job is to implement a system to analyze the worldwide cancer distribution. The dataset comprises the incidence, the mortality, and the prevalence for each type of cancer and their region in 2020. Inspired by the circular glyph in target view, she decided to imitate it to show the information of different cancer types in each region. Step 1. Upload. She uploaded the data and image into the system and clicked the generation button. She immediately noticed the circular glyph in the previewing view in the center of the web page. The two bottom editing panels, circle panel and bar chart panel, and various images in the corresponding options view. Step 2. Binding. According to determined encoding, she dragged the arrow of the new case ratio row to the bar chart in the center. Then she noticed the options shown as 3 columns. In the option view, only the center column corresponds to the actual input data. The left and right columns highlight the encoding attribute for each visual element by changing the value smaller or bigger. For each row, she compared the left and right images to see what the glyph would look like if the value of the data changes smaller or bigger. Moreover, when hovering over the circular glyph image in the options view, she obtained the text describing how the data is encoded. For example, the total risk circle color indicates the color of the inside circle will bind the total risk data. She decides to check the options view to find one she likes. Finally, she chose the third encoding. After selecting one circular glyph from the alternatives, the previewing view will be replaced by this new circular glyph and corresponding details, including the layout and encoding information near the upper right-hand corner. Step 3. Editing. After seeing the default glyph in the previewing view, Lucy decided to make some changes. Satisfied with the inner circle, she chose to adjust the bar chart. Excluding the size encoded with data, she changed the bar chart starting angle by dragging the small button in the corresponding slide. Ultimately, she exported the circular glyph in the form of code, which can easily reuse in her system. With the export file in JavaScript format, Lucy can call the function drawGlyph in her system by giving the variables specified, the center point of expected circular glyph location, the glyph size, and the most crucial part, the data in a JSON format. Moreover, by iterating the functions with different regions' data, such as Asia and Europe, Lucy drew circular glyphs corresponding to continents in one map with effortless ease. Now, we present other examples with different data and example images.